more examples to do here. Now what we're going to do is we're going to solve this polynomial, or this quadratic. And obviously this trinomial, if you notice, we want to see if it's a perfect square trinomial, which it is. Because if we look at the first and third terms, this is a perfect square, and this is a perfect square, so therefore it is a perfect square. Perfect square trinomial. So we can factor it in the way we've taught to do so far. So what we're going to do is we're going to factor this into two binomials. Okay, and what we're going to do is understand that it has to be same signs. In order for it to be a positive multiplied, they have to be same signs. The middle term tells us the sum has to be positive as well, so therefore they're both going to be positive. Same sign same signs when we do perfect square trinomials, opposite signs when we do difference of two squares. Now we're just going to take the square root of a squared, which then would be the first term of both of these binomials, and then take the square root of the last term, which is 3. The square root of 9 is 3, so therefore these would both be a plus 3. Now remember, we're solving this. If you use the zero product property, these are both going to be the same answer if we set them equal to 0, so therefore we don't need to do it more than once. We're just going to set one of them equal to 0. And when we do that, we subtract 3 from both sides, so we get our answer as a equals negative 3. Okay, so we only get one answer here because obviously these would be the same answer. So a equals negative 3. Remember, when it says solve, we have to make sure we start using it in zero product property. Okay, let's go ahead. Now this one you'll notice we had a positive multiplied, positive added, so they were both positive. If we look over here at example 4, we've got a positive. Let's first of all see if it's in a perfect square trinomial, which it is. If we look, the first and third terms are perfect squares. The last term is positive. So this is a perfect square trinomial. So we can factor it using our method. Okay, we know they have to be same signs because the last term is positive. The middle term tells us they're both going to be negative, so we're going to put negatives in both of these. Okay, the square root of w squared is w, so we're going to put a w there. And then the square root of 49 is 7, so we're going to go ahead and put 7 in both of those. Now, we could check this using our table method or our FOIL method, so please make sure you keep on checking those. Okay? So now, because again, these are the same factors, we're going to have to set both of them equal to 0 using the zero product property, just one of them. So w minus 7 equals 0. In order to solve this for w, we have to add 7 to both sides. We get w equals 7 for our answer for this one. So again, perfect square trinomials, remember when you're factoring, this key is same signs. Notice same signs, difference of two squares, opposite. Now I'm going to do one more factoring one, and I wanted to do one like this, because we didn't have one where a was greater than 1. Okay? Now we all learned how to do the AC method. We could use the AC method here, but let's see if there's something special about this trinomial. If we look at our first and our third terms, fortunately those are perfect squares, so we can use this method even when a is greater than 1, instead of having to use the AC method. Again, you could use the AC method here if you wanted to, but it's easier using our perfect square trinomial pattern. So what we do is we realize this is a perfect square, this is a perfect square, and our last term is positive. So this is a perfect square trinomial. So we're going to go ahead and factor it into two binomials, same signs. The middle term tells me they're both going to be negative. So we're going to put negatives here and there. And all we do is just take the square root of our first and the third terms again. The square root of 9x squared is 3x. So both of these are 3x. Okay? And then we take the square root of 4, which is 2. So both of these are going to be 2. Okay? We've factored it, but let's make sure it's right by using our table to check it. Okay, so 3x, negative 2, 3x, negative 2. 3x times 3x is 9x squared. 3x times a negative 2 is negative 6x. 3x times a negative 2 again is negative 6x again. And then negative 2 times a negative 2 is positive 4. Okay? Bring down our first term, 9x squared. Add our middle terms, our like terms, is negative 12x. And then bring down our last term. If you notice, we did get what we started with, so this is a perfect square trinomial. Factored in to 3x minus 2 times 3x minus 2, or 3x minus 2 squared. Okay? And then if obviously you have to solve that, you would just set up 3x minus 2 equal to 0. And you get x is equal to 2/3 for your answer. If you had to solve this. This one you only had to factor. Okay? So that's the end of our notes for 9-7. Okay? And tomorrow we'll be doing 9-8 on factoring completely.